Okay, we're going to continue our discussion about the mathematical foundations of this course. And what we're going to do here is some practice converting from grams to moles and then from moles to grams. And then we'll throw Avogadro's number in there also. So if you haven't watched the vodcast on molar mass yet, you need to do that before you can continue with this vodcast. So if you haven't watched that, go back and watch that one and then continue. Okay, as we work through the next number of vodcasts, you should always have with you a periodic table, a calculator, and then obviously something to write with. But having a periodic table and a calculator handy is important. So if you don't have those things, go get them and then come back and continue. Okay, the first question is, why do we bother to convert from grams to moles in the first place? And the reason is simple. When we write chemical reactions, for example, two hydrogens react with an oxygen to form two waters, the coefficients here in front of the compounds are representing moles. So what we can do in a laboratory is measure things in terms of grams because it's easy to put things on a balance and measure grams. But chemical equations are written in terms of moles, so we need to be able to convert from grams to moles. So you would read this reaction as 2 moles of hydrogen react with 1 mole of oxygen to form 2 moles of water. Now later on we'll talk about how we do this, but for now it's important to understand that we measure grams in the lab and we use moles in chemical reactions, so we need to be able to convert between the two units. So let's start with the first problem here. It says, how many moles are there in 5.6 grams of carbon dioxide? And as we do these problems, you'll see me do the same procedure. You always have something to start with, in other words, a number and a unit, and you're always looking for something. In other words, we want to find moles of carbon dioxide starting with 5.6 grams. So always start by writing the given information, 5.6 grams carbon dioxide. And you always want to write the unit and the formula of the compound you're working with, because as this gets more difficult, if you have that unit and formula, it'll keep your work more organized. Okay, so let's do the dimensional analysis. Let's set up our conversion factor. We want grams of carbon dioxide in the denominator, and we are converting to moles of carbon dioxide. So 1 mole, how many grams? If you remember from our last vodcast, we used the molar mass. So 12 plus 32, there's 44 grams of carbon dioxide per mole. So our grams cancel. When we do the math here, we can do 5.6 divided by 44 gives us 0.127 moles of carbon dioxide. So all we did here was convert a physical entity. In other words, we know how much 5.6 grams of carbon dioxide, and we converted it to this idea of moles. This way we could use that value in a chemical equation. Okay, let's do one more. How many moles are there in 4.3 grams of water? So the given is 4.3, and we're looking for moles of water. So when we're done with the dimensional analysis, the units that should be left over are moles of water. So start with the given, 4.3 grams H2O, set up your conversion. Since we're starting with grams, we want that in the denominator. We're converting to moles, and it's moles of water. 1 mole, 2 times 1 plus 16 is 18 grams. So our grams will cancel. 4.3 divided by 18 gives us 0.234 moles of H2O. Okay, now let's go in the other direction and convert from moles to grams. How many grams, so that's the unit that we're looking for, are there in 0.055 moles of sulfuric acid. So let's start with the given, 0.055 moles. Now the formula for sulfuric acid is H2SO4. And you should know that from our naming unit. Set up your first conversion. Well, now we're starting with moles, so we want moles in the denominator, and that's moles of H2SO4. And we're converting to grams of H2SO4. 1 mole. Let's add up the molar mass. 2 plus 32 plus 4 times 16 gives us 98 grams of H2SO4. Our moles cancel. 0.055 times 98 gives us 5.4 grams of H2SO4. We can do the next one. We're starting with 1.2 moles of nitric acid. First conversion, we want to get rid of moles. Converting to grams, 1 mole. Let's add up the molar mass. 1 plus 14 plus 3 times 16 gives us 63 grams of nitric acid. 1.2 times 63 gives us 75.6 grams of nitric acid. Since we've already talked about Avogadro's number, and if you remember, that's 6.02 times 10 to the 23rd anything, we can incorporate that into these calculations. So we know that 1 mole of anything is equal to 6.02 times 10 to the 23rd of that anything. So if for some reason we wanted to know how many molecules there are in 1.2 grams of dinitrogen monoxide, start with the given, 1.2 grams dinitrogen monoxide. Now your first conversion here, we're starting with grams, so put that in the denominator. Now the only thing we can go from grams to is moles. 1 mole, 2 times 14 plus 16 is 44 grams. So our grams cancel. Now the unit that we have is moles of dinitrogen monoxide, but we want molecules. So what we can do is another conversion. We want to get rid of moles, so moles go in the denominator. We're trying to convert to molecules. And again, this is dinitrogen monoxide. 1 mole contains 6.02 times 10 to the 23rd molecules. So when we do the math here, we can do 1.2 divided by 44 times 6.02 times 10 to the 23rd, and we get 1.64 times 10 to the 22nd molecules of the dinitrogen monoxide. You can see moles cancel and we're left with molecules. Alright, let's go in the other direction. 2.3 times 10, that's supposed to say 10 to the 24th. 10 to the 24th molecules of water. Now you're going to want to be careful between molecules and moles. Don't abbreviate molecules. I know it's kind of a pain to write it out, but the classic mistake here is people write the abbreviation molecules, M-O-L-E, and you can see what trouble that will cause. Alright, so let's set up our first conversion. We want to get rid of molecules, so we need that in the denominator. Molecules of H2O. We want to go to moles of H2O. 1 mole, 6.02 times 10 to the 23rd. So that cancels our molecules, and now we have moles. Well, we want to get to grams, so we can use the molar mass. 1 mole of H2O Add up the molar mass. Moles cancel, and now we're left with grams. So do the math. 2.3 times 10 to the 24th divided by 6.02 times 10 to the 23rd times 18 gives us 68.8 grams of H2O. So as you can see, you can convert from grams to moles and moles to grams, but then you can also incorporate Avogadro's number into there. Now we won't use Avogadro's number much after this unit. That's the whole reason you introduce moles. However, you should still be able to do those conversions.